From the top of a 7-meter high building, the angle of elevation of top of a cable tower is 60 degree and the angle of depression of its foot is 45 degree. Determine the height of the tower. First, let us draw a figure based on this information. So, it is given in the question, there is a 7-meter high building and a cable tower. Here I have drawn a cable tower and the other side a building. Then it is given from the top of a 7-meter high building, the angle of elevation of the top of a cable tower is 60 degree. So, from the top of the building, a person is looking to the top of the cable tower at an angle of elevation of 60 degree. So, the person is on the top of the building and he is looking to the top of the tower at an angle of elevation of 60 degree. Let us draw it. So, we have marked the line of sight. Don't forget to draw the horizontal line. This is the horizontal line. So, here is formed the angle of elevation 60 degree. Then it is given the angle of depression. Angle of depression is forming when a person is looking down. Angle of depression of its foot is 45 degree. From the same position, the person is looking to the foot of the tower at an angle of depression of 45 degree. So, the person is here, he is looking down to the foot of the tower. Let us draw it. So, we have drawn it. This is the line of sight and this one is the horizontal line. And here is the angle of depression. And we have mentioned in the introduction part of angle of elevation and angle of depression that the angle of depression is equal to angle of elevation. So, here we can mark angle of elevation also. It also will be 45 degree. Because this ground level and this horizontal line, these two lines are parallel and this angle of depression and angle of elevation are alternate interior angles. So, they are equal. We can mark here also 45 degree. So, whenever you are marking this angle of depression, remember to mark its angle of elevation also. Now, let us mark the points. I have marked here A, B, C, D, E. Next, we need to draw the right triangles separately. The first right triangle is obviously this triangle ABE with the acute angle 60 degree. Now, here you can see two more right triangles. Right triangle EBC in the upper position and EDC in the lower position. This lower position right triangle is easy to take. You can select any one because both are congruent right triangles. But always we are selecting the right triangle with the angle of elevation. The question is to determine the height of the tower. That means we need to find out this EAC. So, we can use these two right triangles and take the ratio to solve this problem. This ED is the building it has height 7 meter. So we can mark here ED 7 meter. Here also in the right triangle we can mark ED equal to 7 meter. First, in triangle ABE, tan theta equal to opposite side by adjacent side. In triangle ABE, acute angle is 60 degree. AB is the opposite side, EB is the adjacent side. So, tan 60 degree equal to AB by EB. Tan 60 degree is root 3. So, we get root 3 equal to AB by EB. Cross multiplying, we get root 3 EB equal to AB. Let it be there. Now we are going to find out the ratio for the second triangle. In triangle EDC, tan theta equal to opposite side by adjacent side. In the second triangle, the acute angle is 45 degree. Opposite side is ED and adjacent side is CD. So, tan 45 degree equal to ED by CD. We know tan 45 is 1. The measurement of ED is 7. So, we get 1 equal to 7 by CD. Cross multiplying, we get CD equal to 7 meter. So, we got the value of CD, that is 7 meter. Now, you see the figure. This is CD. This value we got 7 meter. But we know this CD and EB both are equal lines because it is the line between this building and tower. So, this CD and EB are equal. So, we can write we have CD equal to EB. The value of CD is 7 meter. So, we can conclude therefore EB equal to 7 meter. Now, we got the value of EB. It is 7 meter. Now, you consider this equation. We have root 3 EB equal to AB. Take that equation. We have root 3 EB equal to AB. In that equation, we can give the value of EB. It is 7 meter. So, we get root 3 into 7 equal to AB. Change the sides. We get AB equal to 7 root 3 meter. So, we got this value of AB. It is 7 root 3 meter. We need to find out AC. Now, this BC also we have to find out. Now, you see this BC. This BC is same as ED. ED and BC both have same length. The value of ED is given. It is 7 meter. So, the value of BC also will be 7 meter. So, we can write we have ED equal to BC. ED equal to 7 meter. Therefore, BC also equal to 7 meter. Now, we go to the value of AB and BC both. We know this AC is the full length. AC equal to AB plus BC. So, we can write we have AC equal to AB plus BC. That is equal to 7 root 3 plus 7. Here you can see 7 is common. We can take it outside. We get that is equal to 7 into root 3 plus 1. That is the value of AC. AC is the height of the tower. So, we can conclude therefore height of the tower is 7 into root 3 plus 1 meter. As observed from the top of a 75-meter high lighthouse from the sea level, the angle of depression of two ships are 30 degree and 45 degree. If one ship is exactly behind the other on the same side of the lighthouse, find the distance between the two ships. So, let us draw the figure based on this information. So, there is a lighthouse of height 75 meter. Then there are two ships, one is exactly behind the other. Then from the top of the lighthouse, a person is looking the two ships, looking down because it is given it is angle of depression. So the person is observing the two ships at the angle of depression of 30 degree and 45 degree. Let us draw it. So the person is here, he is looking the first ship at the angle of depression of 30 degree. This is our horizontal line and this one is the line of sight. This is marked angle of depression. So here we can mark angle of elevation also because we know angle of depression is equal to angle of elevation. So in the first case, I have marked the angle of depression and angle of elevation. Then from the same point, he is looking the other ship at an angle of depression of 45 degree. Let us draw it. So I have marked the second angle also. This is our horizontal line and this one is the line of sight. This is the angle of depression 45 degree. Here also we can mark the angle of elevation 45 degree. Now let us give a name for the points. So I have marked here A, here B, here C, here D. The question is find the distance between the two ships. The first ship is here and the second ship is here. The distance between the two ships is CD. So we need to find out the value of CD. So let us draw the right triangles separately. Let us draw the right triangle with the angle of elevation. The right triangles are triangle ABC with the acute angle 45 degree. AB is the opposite side, BC is the adjacent side. And the second one, triangle ABD with the acute angle 30 degree. AB is the opposite side, BD is the adjacent side. So in the first triangle ABC, tan theta equal to opposite side by adjacent side. Here the acute angle is 45 degree, opposite side is AB with measurement 75 and adjacent side is BC. So tan 45 degree equal to AB by BC. We know tan 45 degree equal to 1. So 1 equal to 75 by BC. By cross multiplying we get BC equal to 75 meter. Let it be there. Now we can move to the second right triangle. In triangle ABD, tan theta equal to opposite side by adjacent side. Here in the second triangle, acute angle is 30 degree, opposite side is AB with measurement 75. Adjacent side is BD. So tan 30 degree equal to AB by BD. Tan 30 degree is 1 by root 3. So we get 1 by root 3 equal to 75 by BD. Cross multiplying, we get BD equal to 75 root 3 meter. So here we got BC equal to 75 meter. Here we got BD equal to 75 root 3 meter. Now you see the figure. This BD is the bigger length. BD equal to BC plus CD. So we can write BD equal to BC plus CD. Here this BD we can replace by BC plus CD. We get BC plus CD equal to 75 root 3. In this BC we know. We have proved BC equal to 75 meter. So we get 75 plus CD equal to 75 root 3. We can take the 75 to right side. We get CD equal to 75 root 3 minus 75. 75 is common. We can take it outside. So we get CD equal to 75 into root 3 minus 1. Now from the figure we can identify CD is the distance between the two ships. So we can conclude, therefore, the distance between the two ships is 75 into root 3 minus 1 meter. A 1.2 meter tall girl spots a balloon moving with the wind in a horizontal line at a height of 88.2 meter on the ground. The angle of elevation of the balloon from the eyes of the girl at any instant is 60 degree. After some time, the angle of elevation reduces to 30 degree. Find the distance traveled by the balloon during the interval. So here is given the figure. A girl with a height 1.2 meter is on the ground. She sports a balloon at a height of 88.2 meter from the ground at an angle of elevation of 60 degree. That means she is looking to the balloon at an angle of elevation of 60 degree. So this is the line of sight and this is the horizontal line. You remember the angle of elevation is starting from here. This height 1.2 meter we are not considering. So here is the line of sight and here is the horizontal line. Then the balloon moved to another position. Then the angle of elevation reduced to 30 degree. The question is, find the distance traveled by the balloon during the interval. Here I have given the name for the points A, B, C, D, E. So the balloon was first at the point E. Then its position changed to A. That means EA is the distance traveled by the balloon during the interval. EA is same as CB. So we need to find out the value of CB. So let us draw the right triangles separately. The right triangles are triangle ECD with the acute angle 60 degree and triangle ABD with acute angle 30 degree. Now you see in the figure this 88.2 is the height from the ground level. But we need only till AB, means height from the horizontal level. So To find out AB or EC, we need to subtract the height of the girl, that is 1.2 meter, from this 88.2. So we can write AB equal to EC equal to 88.2 minus 1.2, that is equal to 87. So here EC is the opposite side with measurement 87 and DC is the adjacent side. Here AB is the opposite side with measurement 87 and BD is the adjacent side. Let us take the ratio. In triangle ECD, tan theta equal to opposite side by adjacent side, that is tan 60 degree equal to EC by DC. Root 3 equal to 87 by DC. Cross multiplying, we get DC root 3 equal to 87. Root 3 we can take to right side. We get DC equal to 87 by root 3. Let it be there. So let us move to the next triangle. In triangle ABD, tan theta equal to opposite side by adjacent side. Tan 30 degree equal to AB by BD. 1 by root 3 equal to 87 by BD. BD equal to 87 root 3. Now you see the figure. This BD is the sum of BC and CD. So we can write, we have BD equal to BC plus DC. So this BD we can replace by BC plus DC. So BD equal to 87 root 3 we can write as BC plus DC equal to 87 root 3. Now here we found the value of DC. DC equal to 87 divided by root 3. Let us replace it here. So we get BC plus 87 by root 3 equal to 87 root 3. This plus 87 by root 3 we can take to right side. We get BC equal to 87 root 3 minus 87 by root 3. To do this calculation, let us cross multiply. So we get that is equal to 87 root 3 into root 3 minus 87 whole divided by root 3. Then root 3 into root 3 is 3. So we get that is equal to 87 into 3 minus 87 whole divided by root 3. By calculating, we get that is equal to 174 divided by root 3. Now you can see the denominator is an irrational number. We need to rationalize it by multiplying it with root 3 by root 3. So we get that is equal to 174 by root 3 into root 3 by root 3. That is equal to 174 root 3 divided by 3. Now we can cancel this 174 and 3. We get that is equal to 58 root 3. So we got BC. BC is this length. This is same as this EA. So it is the distance travelled by the balloon. So we can conclude, therefore, the distance travelled by the balloon is 58 root 3 meter. A straight highway leads to the foot of a tower. A man standing at the top of the tower observes a car at an angle of depression of 30 degree, which is approaching the foot of the tower with a uniform speed. 6 seconds later, the angle of depression of the car is found to be 60 degree. Find the time taken by the car to reach the foot of the tower from this point. So here is the figure I have drawn. It is given in the question. There is a tower. A man is standing at the top of the tower. Here is the top of the tower. The man is here. He is observing a car which is approaching to the foot of the tower. So he is standing here and observing a car at an angle of depression of 30 degree. So this is the horizontal line and this is the line of sight. So here is formed angle of depression 30 degree. So here we can mark the angle of elevation. It is also 30 degree. The car is approaching the foot of the tower. So after 6 seconds, the car reached here. Then the man who is standing at the top of the tower watching the car at an angle of depression of 60 degree. So here we can mark angle of elevation also 60 degree. So this CD is the distance covered by the car in 6 seconds. So here I have marked points A, here B, here C and D. And as usual, let us draw the right triangles separately. One right triangle is triangle ABC with acute angle 60 degree. AB is opposite side, BC is adjacent side. Second one is right triangle ABD with acute angle 30 degree. AB is the opposite side and BD is the adjacent side. The question is, find the time taken by the car to reach the foot of the tower from his point. So we need to find out the time taken by the car to reach the foot of the tower. Okay, let us do it. In triangle ABC, tan theta equal to opposite side by adjacent side. In triangle ABC, theta is 60 degree, opposite side is AB, adjacent side is BC. So, tan 60 degree equal to AB by BC. Tan 60 degree is root 3. So, root 3 equal to AB by BC. Cross multiplying, we get BC root 3 equal to AB. Let it be there. Then take the next triangle. In triangle ABD, tan theta equal to opposite side by adjacent side. In triangle ABD, the acute angle is 30 degree. AB is the opposite side and BD is the adjacent side. So, tan 30 degree equal to AB by BD. Tan 30 degree is 1 by root 3. So, 1 by root 3 equal to AB by BD. Cross multiplying, we get BD equal to root 3 into AB. Now, we can see here this AB equal to BC root 3. So, this AB we can replace by BC root 3. So, BD equal to root 3 into BC root 3. Root 3 into root 3 is 3. So, we get BD equal to 3BC. Now, you see the figure. This BD is the total length. So this BD equal to BC plus CD. So we can replace this BD by BC plus CD. So we get BC plus CD equal to 3BC. BC we can take to right side. We get CD equal to 3BC minus BC. That is CD equal to 2BC. Let us change the sides. We get 2BC equal to CD. That is BC equal to CD by 2. So we proved the length of BC is half of length of CD. CD is the distance covered by the car. This particular distance. It is given in the question. The car is moving at a uniform speed and it has taken 6 seconds to cover this particular distance, that is CD. So the time taken to cover CD equal to 6 seconds and BC is half of its length. So the time taken to cover BC equal to half into 6, that is equal to 3 seconds.